Good morning, everyone. Once more, my name is Teresa, and I'm going to represent you. And I'm from the team of Poland, and I'm going to present you our solution to erratic raindrops. So here is the outline of the problem. When a car moves with high speed in rain, sometimes the drops on its side window walk up but not down. Explain the phenomenon and find the conditions for it to occur. Size of the drops and the car speed, for example. What determines the drop trajectory, and how does it depend on the important parameters? First of all, I will say some things about which important parameters we checked. Then I will present our experimental setups. Then I will proceed to measure dependencies and theoretical predictions. And at the end, I will say some conclusions. These important parameters are the speed of the car, the hydrophobic properties of the glass, and the size of the drops, and we measured all of these three ones. Here we have some underlying physics, because when a droplet moves on a side window, there are some forces, and there is a drag force, a wind force, and a gravity force, and we should take all of them into account. There are also some things that we should also take into account, such as surface tension, cohesive forces, and plus hydrophobicity, which we measured. First of all, we wanted to eliminate one of the factors, just to gravity force. That's why we put our droplets on a flat surface, and here we wanted to focus only on the hydrophobic properties of the glass, of the surface on which the droplets move. That's why we had only here an adhesive force and a drag force. Okay, so we had some results, and the most important factor was a wind force. We saw that droplets strictly followed how we were blowing up, because we were blowing by a hair dryer. We had two setups, one pure glass and another glass covered with Vaseline, and we also checked two wind speeds of a hair dryer, and we saw how, and we were looking how these droplets move. Okay, and the results are here, and it was easier to move the droplet when they were on a glass with Vaseline, and also on a glass with Vaseline, smaller droplets, which weren't moving on a pure glass, were moving on a glass with Vaseline. So we see this is an important factor. And we also saw that cohesive forces made the droplets follow each other's tracks, and because this droplets strictly follow the airflow, here is our hypothesis that it's the same with the car. And here we have a picture from the internet, because we are not the first one who wanted to measure the airflow over the car. Some engineers have it on the daily basis, so that's why we checked such a picture. But we wanted, of course, but it was a special car, and we wanted to do it for our car because it would differ. So here, that's why we set an experimental setup number 2 with ribbons. We put some ribbons on a side glass of a car, and we could divide now this car into three zones. First is turbulent flow, second one is upper part of the window where ribbons went upward, and third one is where ribbons go horizontally, and no matter how fast we go. So only in this part of the window ribbons went up, of course not for all speeds, but for a speed bigger than 35 kilometers per hour. And we checked from 0 kilometers per hour to 130 kilometers per hour, and here these ribbons weren't moving upward. The same here, it was here turbulent flow because of the mirror. Okay, so that's what I already said, that these were our results. And yes, when we were speeding up, first of all, these ribbons were hanging freely. Then they started to be horizontally orientated. I haven't mentioned it was all this table is for second zone in the car, and so then they started to be horizontally orientated, and then they started to rise upwards and in increasing angle. For example, for 40 kilometers per hour, it was 5 degrees. And then they stopped rising, and for this speed they were still 20 degrees, so we can conclude that maybe for bigger speeds it was the same, but okay, we checked until this, because it wasn't possible to check more. Okay, and we wanted to see if the same is with the droplets. That's why we set two experimental setups. First was with a droplet, and it's a third zone, and we see that they move horizontally. And next is yes, it was all in rain, and they go upward, as we see here. Yes, it was. So this division into zones was proper. And we observed also a phenomenon in our car. Then we moved to droplet source syringe, because we wanted to give some results for the size of the droplets. So we produced by a syringe some droplets of this sizes, and we checked which velocity was this in which they started to move upward. We of course put them into second zone, and we wanted to see what was the speed in which they started to move upward. And we see here that for bigger ones, 95 km per hour is the maximum speed. For bigger ones, they don't go like 35 as it was for ribbons. It is because the droplet is much heavier, and there is a gravitational force which makes them for lower speed, which makes the heavier droplet just to fall down. So that's what with ribbons were. With ribbons it wasn't this gravitation. It was much less this gravitational force with ribbons. And yes, our main hypothesis is that that's the drag force, which is the most important factor, because the droplets strictly follow the wind. Yes, and here is our conclusion, that a particular car has been tested, and these results may differ for other cars. And yes, droplets strictly follow the airflow, which observed with ribbons, and the threshold velocity must be exceeded to start the droplet movement. And the threshold velocity depends on the size of the droplets and the properties of the surface, hydrophobic properties of the surface on which they move. Also, yes, as a result of cohesive forces, droplets prefer to follow each other's tracks. There is also a minimum speed above which raindrops were moving upward. If the glass was polished with Vaseline, it was easier to start moving the droplet. Yes, and the droplet's trajectory depends on the place in the window. Here, this phenomenon only occurs here in this place. Here it never occurs because of the drag force. Yes, because the droplet starts moving when a drag force is bigger than another two, so the gravitational force and the adhesive force. Yes, and this trajectory depends on the place of the window, it's the size of the droplet. Yes, because the bigger ones are more likely to fall down. The car speed, yes, because it only occurs yes for the speed. And for droplets for 95 kilometers per hour, and also glass hydrophobicity, as we saw at the setup number 1. Thank you for your attention. Bye.
And for the last has to do so. And about our, first let's make a review. In the presentation, the reporter has talked about some main parts, and I took it in the last. First, he says that the most contribution is because of the wind and it can be taken, and she find out that all the experiments are only taken place in the upper places, and so she talks about the place of the experiment and the speed and the size, right? And well, I think that they do really good experiments, and it shows off. But a question is, they talk about only the size S, and an important question I think is that they give out that about the speed, the 20 degrees, and that is focused on the car right size. Well, I will talk about that in the conversation part. Okay. And well, it's too short, right? Sorry, I have nothing to say now.
Okay. Then we move on to the discussion between the
Yes.
opponents.
All right. So,
So you can ask this previous question and see you can.
Right. Is it possible for you to take your on it now?
Yes, of course.
My PPT is worth
We
nothing.
can exchange the computers.
Sorry.
Is it mine or?
Yeah, maybe here.
Thanks. I'm really sorry. Okay. And as I has talked about in my presentation, I remember you got a conclusion that the average degree is about 20, right? About the speed. When the speed is is more than 50 kilometers.
Yes, when it's more than 50 kilometers.
Okay.
It's all ribbons in the second zone. They are in an upward position from a horizontal to this angle is 20 degrees.
About 20 degrees.
And yes, about there are some fluctuations because it's not so stable process. But the most important thing here is that it doesn't change from 50 kilometers per hour to 120.
Yes. I just want to know that is this 20 degree depend on the glass of the car or the speed and or the size of the drop or something else?
Of this you asked the size of the car.
The size of the car glass.
The size of the car glass. Okay, we did this measurement only for one car.
For one car.
We had only one car to possible. So yes, it could differ for another cars. Yes, but we haven't checked it.
All right. I get to know that. And
the rest of your question, could you please repeat?
I just want to get an example. So can pass on to the next one. Okay. And I think you divided the glass of the car into 3 parts, right?
Yes. Why? Because we saw here that these ribbons in the first. Okay, we saw the difference between in their movement as we speeded up. Some of them went upward, but some not. And may I? Here, at a certain speed, right. It was 35 kilometers per hour. These ribbons went upward. Yes. And here they didn't. No matter how fast was the speed. It supports our hypothesis that the most important factor is the drag of the drag force.
The main question I am thinking about is how you get this one.
Here we saw that it's turbulent flow. It was because of the mirror, yes. In this previous, here you see in this simulation made by...
When you put this picture here, there isn't a mirror, right?
Yes, that's exactly what I'm saying now. Here you see here there are no mirrors. That's exactly the point. And here we have mirrors, and it makes the flow turbulent. And yes, we should, if we hadn't have a mirror, okay, it wouldn't be safe to write. So,
all right,
so,
all right.
But this mirror gives a turbulent flow, and we can see it here. Really perfectly.
So here comes another
we saw
question.
that it was.
If you choose this piece of glass to do your experiment, when car is going on, the with the point move, the way the point move is on the same way with the wind or with the car, right?
No.
Just move along this one, right?
The wind.
The ring point.
The wind point. What's wind?
Ring point.
Wind
The
point.
drop. Water
Water,
point.
drop,
Water point
droplets.
moves along this one, right?
Yes, we also it was just it was a video which I showed, but we also observed that they moved here.
Oh,
yes.
yes.
I just chose one to
show
show
just the
you.
way, all right? I'm thinking, here comes another question, right? Here, this way they move in the same way, and if the drop is not moving on the same point, let me make an example, right? If I put the point on these glasses, so would it be the same conclusion?
Here, where? Here?
Here, right?
Okay, the task was about the side window, so it's a front window, so we shouldn't concentrate on it. But okay, we should check. We can only speculate because it wasn't about the task wasn't about it.
All right.
Discussion. So it's now technical questions from the reviewer.
Excuse me. Yes, first question about your first experiment. How did you hold the hair dryer? With hand?
With static.
Okay, thank
Try.
you.
Tripod.
And continue the theme of hair dryer. Was the velocity of the droplet blowed by hair dryer uniform or not? Just one word. Uniform or not?
The velocity, we have two speeds, two velocities. We could change it.
One droplet.
One was year of it.
One droplet. One experiment. One time. Was the droplet moving uniformly or not uniformly, slowing down or speeding up?
First of all, okay, it was first of all it started to speed up, yes, because yes, it was speeding up, and then he kept the
I probably
constant.
have to complain a bit about this as well. So try to focus your technical questions on things related to the presentation.
Slide 9. Slide 9, please.
Okay.
Yes.
What do the colors mean?
What?
What do the colors mean?
The pressure of the air.
And
Yes,
which color is for higher pressure?
Red.
Good afternoon, ladies and gentlemen. My name is Alexandra Maslakova. I represent the team of Russian Federation, and I'm going to present to you our review of problem number 14, Erratic raindrops, presented by the Poland team. Okay, let's go to the. This is the statement of the problem, and let's go to the review of the report.
I think only one reviewer on the floor. I'm not sure that you're allowed to have a photo.
Okay. So, first, the reporter presented us their setup and first experiments when they stated that the droplets move only by direct force of air, but they didn't fully investigate all the forces that they presented in the beginning. They told about like 5 or 6 different forces and only investigated the adhesive force and the drag force. Then the methodic of the experiment was not clear because there weren't any photos of the experimental setup, and we couldn't know if the experiment was clear enough. When the reporter made a hypothesis that the droplets follow the air around the car, they didn't prove it by things like Stokes number, if it really goes by its a weight or something drags it, then and they are, no, I'll go to the next slide and tell you about the advantages and drawbacks of the reporter. Reporter did a lot of, well, not a lot of, quite a lot of experiments with different kinds of setups, which were interesting but still not clear, and the acting forces were found out, but their influence wasn't investigated, though, as I said it before, and some dependence of critical velocity for droplet motions of the signs was presented, and then they discuss it in the opposition. Points to improve? Well, there are a lot of them, but two most important are better presenting of the results, like plots and not tables, and further investigation of different forces. Well, opposition was quite short. Opponent almost said nothing, and they discussed not very important questions like limits of speed for different cars. Well, that is interesting. And then you discussed dividing window into 3 parts, and it took a lot of time, almost the whole discussion. And I think there could be more interesting questions to discuss.
Thank you.
Okay, so we're going to the discussion.
Yes.
Come here, please. Well, I'd like to start with the second question. Why do the drops start to move?
Because, okay, when the drag force is bigger than adhesive force, it started to move. And the sum of, okay, gravitational force and adhesive force.
Okay, what's your opinion on this?
I believe that it need to move before the wind is come, and well, and then the speed. All right.
Window speed?
Then the speed of the car. It led the.
But well, speed of the
English
car
is
is not
difficult
force.
for me.
Can you please tell it in the terms of forces?
Right.
So
When it has a speed before, the wind force it to move in another way, like this. Okay, is that?
so you agree that the only that determines the trajectory of the droplet is the air flows,
Oops.
like where the air goes. Okay, let's go to the next question. What is the role of glass in the beginning of movement
beginning-
and then the during
Okay,
the
you're saying about this experimental setup number 1, yes?
yes, and
Okay, we wanted just to show, okay, we wanted to eliminate another variables, and just to focus on this, and we wanted also to show, to show the main thesis from this experiment. Yes, and show how the hydrophobicity changes this adhesive force, and we saw that it gets smaller.
okay, can it happen that a drop is not moving continuously, but it actually, like, I don't know, tears and then jumps? I don't know. Can it happen?
You meant that it stops and then moves.
No, I mean if it's like part of it is disconnected, and then
You meant, okay, you mean that the drop is, for example, moving, and then for a bit slower down, yes? Slows
no,
down?
I mean it divides into 2 parts.
Okay, it divides into 2 parts. Okay, here we have many forces. First of all, we have many variables we can't control. I think it's more likely for a droplet not to divide into 2, but it's more likely just from the 2 droplets to form one bigger. It's we saw this in our experiments that it was more likely they preferred to form
Yes,
one.
I got your answer. What's your opinion on
forces.
this?
About whether it will.
Can they divide?
I think yes.
Why?
So it is depend on the glasses. So when it is moved, and one surface of the drop is depend on the surface.
Yes, we can also see here that the glass isn't polished very.
The glass will never be smooth.
In every place the same. So that's why there can be some movements such as dividing into two because because another forces.
Okay,
The
we
teams
have
may
a
now-
question from this team. Question.
I'm sorry. Please, you told about the drop dynamics, but couldn't you, for example, draw on the board what forces acts on the droplet while movement, and why it doesn't move, why sometimes it moves and sometimes it don't move? What are the main forces acting on the drop when it moves?
I've already said it.
Please, on the board and
I
in the
can
comment.
show it in this presentation. Maybe is it possible?
Yes, Sophie.
Okay, so take it.
Are there any other questions while we are preparing to answer this one?
Sorry?
Any other questions? No?
Yes, I've got a question to the viewer. What do you think about your question? What would be your answer if this droplet could divide into the smaller ones? Have you made some
I think
measurements?
my question was not got by the reporter
Okay.
and the opponent, but they answered another one, and yes, they can. And okay,
And
that's
so,
the answer.
I have some technical problems. I don't know how to just. But okay, these forces are escape forces, drag force, and force of gravity. Yes, these are main forces, the most important ones.
And it doesn't move to the certain speed because of
There should only be 2 reporters on the floor. That's also true for the discussion. I will allow you to have a helper if you have a problem with the laptop though.
what we can join the discussion.
You can join the discussion, but you may stay by your side.
And I think the question you should ask, okay, the question which is the most interesting here, how does it depend for the other cars? Maybe there are some cars in which this effect doesn't occur at all. It is possible, yes, because that's such a thing that we haven't actually measured, and maybe there are some cars.
Yes, I just want to speak about that. About the glass, and I have talked about that. They are not ideal smooth, right? And an important question is when water is on the glass. It is a bit about chemistry. The atoms are connect to others, right? It is glasses. So this may become a force that let not it move upon the runway. So what about that?
Did you understand the question? Because
I didn't actually.
Sorry,
Okay,
got
since
another
we have
questions.
a-
I go to check over.
Okay, we have a lot of questions
Yeah.
here.
so
Okay, you have
that was
3 hands.
A short question. What was the contact angle between the glass? What was the range of
So,
contact angles
I would
between
like the
the
opponent back on the
water
stage.
and the glass that we used? Contact angles.
angles of what?
The angle between the surface of the vehicle.
The surface of a glass. For example, a side window is like this, yes? On a car.
No, for example, if we put the drop on the.
I can show it.
Thank you very much.
Yes. So this is the glass. This is a droplet. And what is this angle? This is basically the contact angle.
This angle.
If you don't know, just say it.
I would like you back there as well.
Thought you had investigated this.
No, we haven't investigated.
Okay, I have a
We
very
can
short
say that.
But if you don't know, just say don't know. We'll get to another question.
But
Please,
we
we
can
have
just say that
not
this-
that much time. Please,
that
I ask you.
We can explain that this problem
Thank
For
you. What
bigger
if
ones,
the car would be rectangular? A box. What if the car would be rectangular, like a box? What would be the trajectory of the droplet?
I think that's a very nice question. I think this phenomenon it was a possibility that it didn't occur at all, because we thought that they move upward when we see this.
Okay, thank you. The time's up. So we now turn to the concluding remarks by the reporter. So they're going to stay on stage. So you have 1 minute.
Me? Okay, I thought reporter is China. Chinese. I'm mixing the two. The reporter is.
Moving on.
Okay. To conclusions. I really liked your questions about about the rectangular car, and I think the most important thing here is the drag force, which influences the trajectory of a car, and also these parameters which we can see here. And yes, there is still a question how it happens with another cars. Yes, and so that's I think all about this drag force. But if I have just one little time, I wanted to see that here is these forces are proportional to r and r squares. I haven't written it here, but
Thank you
I
very
had
much.
more time just to say.
Thank you.
Okay.
Okay, so we should thank the reporter. Then we turn to questions from the jury. So we start with the Amy.
Thank you. Could you show the slide with the simulation of the flows, of the air flows?
Yes.
Looking at this slide, do you think the front windows play any role?
The
on
front window.
Yeah, on the character of the movement of the drops on the side windows.
Yes, it could play a role. In fact, we were just yes, we were thinking about it, and it could be. We also measured some things with because we thought that maybe it was the speed of the wind, and it was all connected with Bernoulli law. We checked with a pilot type, but the Bernoulli law doesn't apply here, because these differences of a pressure, they are very small, and what front glass could make these differences of a pressure, but it's very small, so we just.
And do you think there might be difference in the behavior of the drops depending on the initial condition? So, for example, whether they come from the front window with the initial velocity, or whether you put them with a syringe just with a zero velocity?
Oh yes, of course it could influence this, because this droplet with a zero. Okay, these ones which go which have already a speed, they don't have to move this up to conquer this friction force and to start moving, and it's the bigger force you need just is to start the movement. Then to follow it, it's easier. Yes, it's very good question, in fact, and this velocity should be in which they move. For droplets that they go, we don't need to start them moving. This velocity should be lower because they already move, and we don't have to push this friction forces. I really like this question.
As I understand, your experimental results concern only one particular car, is very so. But if you were able to construct a car by yourself, what do you think? Is it possible to construct a car for which critical velocity for drops to walk up would be, for example, 10 kilometers per hour?
Yes, okay, maybe not 10, because the rhythm started to move upward at this approximately 35 kilometers per hour. So and they were very light. So I think it's but maybe it's this threshold velocity from which we can go down. But yes, for example, if we have a car and we can just the side window is not straight, but just more all the window, not only that, because here this part of the window was a bit from in an angle, yes, and that's why maybe this phenomenon occurred, and maybe here it was more straight. So if we slope the whole window, it could be better, and not only here droplets would move, and also here, and we also can have a lower speed if we slope this window more than in our setup. Yes, it's possible. Yes, I think it's a clue.
What critical velocity
I'm
do you
sorry,
call?
we
To
should
build.
take one question per jury member. So any other jury member? Otherwise, you can continue. No one? Okay, then you can actually ask your question.
And what critical velocity do you hope to achieve?
Critical.
35 kilometers, maybe less, maybe.
Yes, I think critical it would be 35.
Not
Okay,
less.
because you see, yes, you think it would be approximately the same as with ribbons, but we don't know. We haven't checked it.
Is it your intuition?
Is it what?
Your intuition simply, or something like estimations, calculations?
Yes, it's the experiment with the ribbons. They are very, very light. They weight much less than a regular droplet. Their weight is less than this than this. So okay, it's milliliters, but we can transfer it into kilograms, and so it's less. So. Yes, we can have this phenomenon. Yes, so for the ribbons, yes, okay, we can only speculate how it would be for another cars because we haven't measured it. But I'm quite sure. The thing I'm quite sure is that when we have a window in an upward position, it wouldn't occur at all.
So it's quite clear that if you have a hard wind that blows upwards, a drop can move. And there was mentioned here that maybe there could be other conditions that even if the wind is not going upward, is it possible, do you think, for the droplet to still move upwards?
I think it's quite connected with the Bernoulli law that it could also. That's the same question we ask ourselves. That maybe droplet is in a shape of a wing of an airplane.
That would be the main reason.
That
it would move upwards even if the wind is like that.
I think so. Yes.
Okay.
And
So
the winds.
else has another reason. Do you think they agree with this? That would be the main reason for it to move upward even if the wind is not that way.
Not quite. And the change of wind
Okay, so you
speeds.
Okay.